Hello students, we are going to see that what is linearly dependence and what is linearly independence. So basically dependent vector means you can get the vector from the linear combination of another vectors, and linearly independent vector means you cannot get the vector from the linear combination of other vectors. So let's see official definition. Linearly dependent vector. I'm sorry for the bad handwriting. I'm not very used to this S pen. Let capital V be a vector space over a field F. When we take this field as a set of real number, then we call it real vector space. Okay, the vectors v1, v2 and so on, vn are said to be linear dependent if there exist scalars a1, a2, a3 and so on, and not all zero. That is that is the main thing in linearly dependent vectors definition, that these scalars cannot be all zero, such that the linear combination of these vectors, that is a1 v1 plus a2 v2 plus a3 v3 and so on, an vn equal to 0. If we take linear combination of all vectors equals to 0, and if they are linearly dependent, then you will get at least one AI that is not 0. Okay, now we'll see example of it. Linearly independent vectors. What is this? That is not linearly dependent. That is vectors v1, v2 and so on, vn are called linearly in Li vector if whenever a1 v1 plus a2 v2 and so on, we take linear combination of these vectors, then all the scalars are 0. This is the definition of linearly independent vector. If these set of vectors are linearly independent, then the linear combination of them, in the linear combination of them, all the scalar quantities are 0, then we say that these vectors are linearly independent. And linearly dependent vector, in the linearly dependent vector, the scalars are not all 0. The only difference is in the linear dependent vectors, in linear combination of vectors, all the scalar are 0, and in LD vectors, not all 0. Let's see an example of it. We have u equals to 1, 2 and v equals to 3, minus 5. And we have to check that these vectors are linearly dependent or independent. There are two ways to check it. can make a matrix of these vectors and check if the determinant is 0 or not. If the determinant is 0, 1, 2, 3, minus 5, if the determinant is 0, then the set of vectors are linearly dependent. If not 0, then linearly independent. And another traditional method is take their linear combination and check if the scalar quantities are 0 or not. Now, what will be? A, 2a plus 3b minus 5b equals to 0. A plus 3b equals to 0, 0 vector, that is 0, 0, comma, 2a minus 5b equal to 0, 0. Now, a plus 3b equal to 0, 2a minus 5b equal to 0. If you solve them, you get two a plus 6b equal to 0. Now you subtract this, then you get 11b equals to 0. That is b equals to 0 and a equals to 0. So you are getting the scalars are 0 in the linear combination of this vector. Hence these vectors are linearly independent. Hence these vectors, given vectors, are linearly independent because scalar quantities are coming on 0.